right? And I've never done practice finals before. It's my first time, 25 years of teaching. People have always bugged me for a practice final, begged, and I'm like, no, just look at the old practice steps. So I put them all together into a practice final. I'm hoping that does magic on the final. Show me the magic, all right? I'm wanting a bunch of A's on that final, I hope. All right. So you all will affect whether I finish my last 15 years giving people practice finals or not. If it makes no difference at all, I'll think, well then, who cares? No, I'll probably give it a couple tries, but you will have an effect. All right, so here we go. Find the average rate of change for the given function. Average rate of change. These are our last 11 questions in the course. What does that mean, average rate of change? What's a rate? Can somebody give me an example of a rate? What's a rate? A rate. Rate. When you drove to school today, did you go at a certain rate? Did you do 55 in the parking lot? Probably not. Hopefully not. But you might have done 55 on the freeway or even 60. All right, what if you did 60? 60, what? 60 miles per 1 hour, huh? Now, I know we just write MPH, but that's what it really means. Huh? It means 60 miles every 1 hour, doesn't it? If you stayed steady at that rate, 60 miles per hour, for 1 hour, how far would you go? 60 miles. Hence the name, right? 60 miles per 1 hour. That means if you drive at that rate, every hour you'll cover 60 miles first hour, 60 miles second hour, 60 miles third hour, right? That's what 60 miles per hour means, huh? By the way, how many miles are you going every minute? If you're driving at 60 miles per hour, you're covering what? A mile a minute, right? I remember my dad saying that to me when I was a kid. If you're driving 60 miles an hour, you're covering a mile a minute because there's 60 minutes in an hour. So you're doing a mile a minute, aren't you, at that rate? That's a rate, isn't it? How about if you say, I do Math Excel homework as fast as I can, and I can do 3 problems per minute. 3 problems per 1 minute. That'd be pretty quick. I'd be impressed if you could do that. Probably not, huh? 3 problems per 1 minute is how fast I can do Math Excel homework. What if I say I can grade papers, and I can grade 10 papers per hour? Notice, those are all rates. Those are all how fast something happens, huh? Notice that they're all fractions. A rate is a fraction. And where's the time? Bottom. Do you realize that? Rates are fractions with time on the bottom. That's what it means to be a rate. You're a fraction, you get time on the bottom. Okay, great, so what? Well, do you remember from your algebra days that slope, how do you calculate slope? Remember the formula for slope? Anybody remember that from your algebra days? Rise of a run. Yeah, rise of a run. Well stated. Rise of a run. And then, can we say even more? How do you say it in terms of like x's and y's and stuff? Yeah, the slope formula is y2 minus y1 over x2 minus y. Y equals mx plus b is the general equation of a line. But y2 minus y1 over x2 minus x1 is the slope formula, isn't it? Remember that from your algebra days? Those bring back sweet memories of your algebra experiences? All right. So notice that a slope is also a fraction. So what? Well, that means that if they give me 2 points in time, like they are here, they're calling it x, but whatever, 2 points, and I convert it to a fraction can be a rate, and a fraction can be a slope. So in other words, a rate is a fraction, is a slope. Slopes are fractions. Slopes are rates. That ever occur to you? You ever stay up late at night and think, rates are really slopes? Probably not. That's what strange math and science teachers do, but that's the truth. So, with all that said, when you read on the I'm trying to help you, because a lot of the battle on a final, math final, is identification, isn't it? There's so many things we've done over these 18 weeks. When you see average rate, you think slope. Trying to make that connection for you. As soon as you read, and there'll be two of them, right? Two of them from 11.3 on the final exam a week and 2 days from now, and it'll say, find the average rate of change, and you think slope. And by the way, you get a full sheet of notes, don't you? I don't know if I said that. For the final, full sheet of paper, both sides, write anything you want. Not just a 3x5, but a full sheet, anything you want, both sides. Okay, so what then? So this is slope. With all that said and done, how do we actually do it? Well, so as soon as we see rate of change, we think slope, which is y2 minus y1 over x2 minus x1. You remember from algebra. Okay, let's do the bottom. What do you think the x2 and the x1 are on the bottom? I mean, if your life depended on it, you had to lay down a bet. Looking at those words, what do you think the x2 and the x1 are? Wouldn't this be x1 and this be x2? That's exactly what they are. So it's 6 minus 0 on the bottom. So far, so good. The two x values are the x1 and the x2. Now, but how do we get the y values? I don't see y anywhere. X was pretty obvious, but I don't see y anywhere. Any ideas? What do we do to get y? Yeah, exactly. Do you remember from your algebra days that y values are f values? Function values, f, g, h, whatever your function, that's a y. That's by common agreement in the math science world. They said, hey, function values are y values. So therefore, when we have the slope formula, y2 minus y1, we should think, oh, that means f value minus f value. So that means f of x2 minus f of x1, meaning, let's just get rid of the x2, x1. It's f of 6 minus f of 0 over 6 minus 0. Are you tracking with me? Because this is really a y. F of 6 is a y. F of 0 is a y. So I just got to plug in 6 to what function? To this function right here, huh? So f of 6, I'll bring this straight down here. F of 6 is going to be 6 squared plus 3 times 6. That's f of 6. Minus, and now comes, so there's f of 6 minus f of 0 is 0 squared plus 3 times 0 over 6 minus 0. Everybody see what happened? Right? This is f of 6. See how I plugged 6 into that function? See the x squared plus 3x function? I just plugged in 6, 6. Didn't I? Does everybody see that? I plugged in 6, 6 there. I plugged in 6 and 6 here and here. So f of 6 is all of that. And then I plugged in, for f of 0, I plugged in 0, 0, and got that, huh? So what does that all come out to be? I don't know. 36 plus 18 minus 0 over 6, which is some kind of big number. What's that? 54 over 6. Is it 9? Yeah. And all is said and done. It's 9. There we go. So do you see what we did? We just found the slope, which is the average rate of change. Anything I can help with on that? So what did we really just do there? I want to make sure, 'cause I don't like math being, make believe, strange. That means if you graphed this thing, this is the function x cubed plus 3x. At 0, if you plug in 0, it's here. Right? Remember when you plug in 0, f of 0 just comes out 0. And when you plug in 6, f of 6 comes out, 54. So at 1, 2, 3, 4, 5, 6, so from 0 to 6, this thing goes all the way up to 54. Does that make sense, what we just found? There's some kind, and I don't know what it does in between. Well, actually, I do know. It does something like that. So the graph, it's an x squared graph. Remember, x squares are U-shapes, they're parabolas. So basically, it goes over here also. But anyway, all I care about is what it does between, on the x-axis, between 0, and here's the x-axis, right? And over here is the y-axis, or the f, the heights. So basically, if you're a person, and you are a person, if you're a person riding on a roller coaster like that, and you're going from this spot to this spot, you're going from 0 to 6 on the x-axis, and your height is going from 0 up to 54 feet. Does that make sense? I just want to give you a picture. No picture is required, but I think the picture will make you feel what we're doing and remember the steps better. Basically, what we just did is we just said, hey, if we went between 2 points, height of 0, way over there, height of 54, because if you plug in 6 to this function, right, 6 squared plus 3 times 6, 6 squared plus 3 times 6 came out 36 plus 18, 54. So as you go from x is 0 to x is 6, you're at a height of 0 to a height of 54. You went up 54. Well, how fast did you go up? Like, how fast was your height rise? Like, if you're an airplane and you're gaining altitude, you're a roller coaster, gaining altitude, how fast did you gain altitude between those 2 points? Well, you gained 54 feet of altitude, right? You went from 0 to 54. It's a 54 there. Over a distance of 6, over a horizontal. Or like if you're driving up in the mountains, you know how and if you start getting really steep, you'll see the sign that says 4,000 feet. And then just a few minutes later, 5,000 feet, 6, and then you know you're going up fast, right? If those elevation signs are popping up quick. So that's the kind of thing. How fast are we rising? That's what we just figured out. What's our rate of change? How fast are we rising? While you travel 6 feet sideways, you climbed 54 feet in altitude. So 54-foot climb over a 6-foot horizontal trip is 9 feet per horizontal foot. You're climbing up 9 foot every 1 foot you go to the right, on average. Does that make sense? As I went 6 feet over, 6 times 9, 54 feet up. I rose, the airplane was rising, our car was rising in elevation, on average at a rate of 9 feet for every sideways foot I went horizontally. In other words, that's the steepness there. That's the average steepness. I keep calling it average steepness because in reality, in the beginning of the roller coaster, right in here, it's less steep. And then over here, it's even more steep. This is the average steepness, the slope. That's what a slope is average steepness between 2 points. If you want to learn all deep mysteries more about that, it's called calculus. That's what calculus gets all into. That's Calc 1. That's what Calc 1 is. One of the main themes of Calc 1 is rates of change and steepness and tangent lines, which are lines that barely touch a curve, all that kind of thing. That's a lot about what's there. That's what we're doing. We're basically hinting at calculus today. This is the intro to Calc, basically. That's what they want us to do at the end of this finite math class is intro to Calc. So this is an intro to Calc. Average rate of change is slope. It's steepness of a function. All right. Okay. So same kind of thing. Average rate of change. There's my function. There's my x1 and my x2. So what's the formula? What do you write out for the formula to find the average rate of change? Slope equals, what is it? y2 minus y1 over x2 minus x1. Remember the slope formula? And instead of y2 and y1, what do we put there? How do you find y2? F of, and this is the x1, x2 up here. So it'd be f of 5 minus f of negative 1 over 5 minus negative 1. Correct? So it's the difference of f values, because that's y values, over the difference of x values. See what I did there? So now you got to calculate that. Plug that stuff in. Okay, so f of 5 means plug 5 into the function. And f of -1 means plug -1 into the function. How are we doing so far? Right, this right here is f of 5. This right here is f of -1. Good so far? Are we quite happy? So then this is 1 over -3 minus 1 over -9 over 5 plus 1, which is 6 on the bottom. Huh, let's make that 6 on the bottom there. Good so far? We got a lot of minus signs on this one. What do we do with that thing? Any ideas? How do we get rid of these fractions? We don't want fractions, do we? Yeah. Multiply by the common denominator. What's the common denominator? 9. Because 3 goes into 9. Common denominator would be the thing that can hold them. So, well, actually, yeah, that's common denominator, 9. So, first off, what do these two negatives do right here? Positive. You okay with that? A negative in the bottom of a fraction just comes to the front. Let's just make that positive. Okay, so now what you do is you multiply it by 9 and by 9. Is that okay just to multiply the top only by 9 like that? No, I have to also multiply the bottom so I don't change the fraction, huh? Right? You got to do the same thing top and bottom so you don't really change the fraction. Remember all that kind of truth about fractions? Okay, so what does that mean? What happens here? 3 goes into 9 3 times. Here 9 cancels 9. I'm just cross-canceling fractions. Is it getting too messy? What's that going to leave me? -3 plus 1 over 54. -2 54ths, reduce it, minus 127. Done. How are we doing? Did you track with me there? How about I do like an instant replay? Can we have an instant replay on that action? Let's do that one more time. So again, this was 1 over -3 minus 1 over -9, wasn't it? Right. So that's one of the first things is these guys both become positive because there's two negatives. Good. Good on that. And now I'm going to multiply top and bottom by 9. Yeah.
Why can't you just multiply 3 by the left fraction and just so you don't have to simplify it from there?
Do what's that?
Why can't you just multiply 3 to the 1/3 for the top and bottom and just add it across?
Oh, I see. Yeah, you're saying, yeah, can't we just multiply top and bottom by 3, get common denominator, that would be minus 3/9 plus 1/9 all over 6, that would be minus 2/9 all over 6. You could. That's not, see how that's more steps? And then, because we're not done, we can't leave it that way. This is still ugly. Now we got to do something else. So it's valid, but I'm showing you a quicker way. And it could, and these can become even worse. So, so there's two strategies, both are true. So one of them is just take just this guy. It's better to do everything at once, it'll be quicker. But that strategy is valid. Take just this guy, make them common numbers, combine them, then what would you do from here? This is 6 over 1 down here. This is the main bar here. You've got to flip him up, multiply by 1/6. Yeah, that'd be minus 2/54. Same thing, huh? That will work, not as easy. I'm showing you an easier way. Does everybody see what I'm showing you? Instead, quicker, less steps. would be, instead of just dealing with the 3, let's wipe out all denominators in one step. That's why it's quicker. So consider them both and say, look, 9 will take care of both of them. Why mess around and do half of it? Let's just do 9, and I go 9, 9, 9, top and bottom. These are really 9s over 1. 9 over 1, 9 over 1 is what they really are. Right? Any whole numbers over 1. So that's why they cross-canceled. 3 went into 9 3 times. And don't forget about that negative here. And this is not a negative there. That negative there, that was an equal sign. But this negative, so that's why it came out negative 3 there. And these guys canceled. That's why it came out plus 1. And the bottom, 6 times 9, 54. Everybody see what I did? It's all making sense. So there's our answer. I reduced the fraction. Minus 1/27 when I divided top and bottom by 2. How are we doing? So these are the same every time. Average rate of change, it's f minus f over x minus x, because it's difference of y's over difference of x's, rise over run, slope. All right, let's try. Destiny, you had me for calculus.
Yeah.
So you remember all this perfectly, huh? You could do the lecture.
No, it's okay.
I'm just kidding. It's been a while, hasn't it? Wasn't it a couple years ago? Something like that?
2 years ago.
Was it 2? Yeah, so I was thinking 2. So you might have forgot 1 or 2 things.
I miss it though.
All right. So let's try that. Average rate of change of the function. So same kind of thing. It's basically a fancy way of saying slope. Average rate of change. A rate is a fraction. A fraction is a slope. That's if you go on to a business degree and they make you take any kind of business calculus or something like that, the main concept you want to get out of this section is a rate of change is a fraction is a slope. That's a big theme in Calc 1. Any rate of change is a fraction is a slope. So y2 minus y1 over x2 minus x1. So take it from there. So in the bottom. So what's my x1 and my x2? These guys, right? x1, x2. Put them on the bottom. 4.5 minus 4. To there. And now, what do you do on the top? What is y2 and y1? Well, it's f and f, isn't it? Y values are f values. So in other words, it's f of 4.5 minus f of 4. Everybody see how that always is the same deal? Let's look back. Let's compare. See this one right here? It's the f values on the top. It's the two x values on the bottom, and f of those guys right above them on the top, with minuses in the middle, top and bottom. Right, look back to the first one we did. Same thing here, right? X values in the bottom, f of those on the top, minus signs in the middle. So it's the same thing here. X values on the bottom, f values on the top, minus signs in the middle. It's the same every time. That's y2 minus y1 over x2 minus x1. That's the slope formula. Okay, let's crank it out. I'll do the bottom, 0.5. Here we go. How about that top? Well, you just got to plug into that ugly function. And we're going to basically use our calculator. There's no fancy stuff other than calculator. So 0.4788 e to the 1.31, this is ugly, 314 square root of 4.5. That's where the x is. You plug the x in right there, don't you? I am totally out of room already. I'm going to have to bring it down here. This is a crazy one. So here we go again. So the bottom is 0.5. The top, f of 4.5, is 0.4788 e to the 1.314 square root of 4.5 minus 0.4788 e to the power 1.314 square root of 4. Everybody see what I did there? There's f of 4. And there's f of 4.5. See how I just plugged in 4.5 and plugged in 4 to the x slot. That's the holes in the toaster. That's what an x is in a function. Insert here, right? That's where you plug in the whatever's in the parentheses. right? 4.5 in the parentheses, plugs into the X slot. 4 plugs into the X slot. And then it's just hit the buttons on the calculator, and I didn't even bring my calculator. All right, let me grab it. Okay, I was able to get the E button. E button, it's above the natural log. Hit second natural log. This is a long one. Square root's above x squared. Did y'all find that? I got, the whole thing came out to be how many places they want? 3 places. 2.291. Did y'all get that? 2.291. So, let me show you a thing or two about, because this is a hard calculator one, about using your calculator in a way that'll be easy. Basically, when you type this first thing in here, I would just go 0.4788 e to the power, right? It shows you got to hit that second ln, e to the power. It does parentheses automatically. 1.314, and then you got to go times, right? Because there's an understood times right here between the 1.314 and the root. There's nothing between them, which means times, doesn't it? Times square root 4.5, and I would just hit equals right there. Look, I didn't even close off the parentheses. I didn't do anything. Who cares? Just, if you're going to end it, and that'll just be the first answer. Just hit enter right there. You don't even need to close. You don't need to put closing parentheses if there's nothing more after. Just hit enter, and what did I get there? I got 7 point, came out, in this first part came out 7.775226.785. Did y'all get that? Get that first part? Okay. We good? And then, don't even skip a beat. Don't even hit anything. Just right away, hit the minus sign, this minus sign right here. You guys tracking with me? And it'll automatically put the word answer in front. It means, oh, you want me to subtract the last answer, which is perfect. It's exactly what we want. Do you know about using your calculator that way? Using the previous answer? Just hit minus, and it'll go answer minus. And that's more like, yep, that's what I want. I want that last answer minus. And then basically do the same thing. 0.4788, e to the power, 1.314 times square root of 4, and hit enter. And it will give you an answer. And then go divided by, and it'll go, oh, answer? Right, divided by 0.5, enter. So that exact typing on the TI-84 or 83 should give you the answer, 2.291. Is that working out now? You good there?
So for square root, are we pushing second and square root?
You're hitting second and the x squared button.
Yeah.
So yeah, you got to get the thing above. Yeah. Is that good? How are we doing? All right, let's move ahead. They're trying to sink in the concept. I'm glad they're doing that. That's the purpose, to get you ready if you're going to take Calc, a little introduction to calculus. So use the graph to estimate the average rate of change of the percentage of new employees from each period. So from 94 to 2000. So here we go. And it's all by the graph there. So they're saying, hey, between 1994 and 2000, what's the average rate of change of the percentage of new employees? So what are we talking about this? This is an employment graph. This would be something that HR would use, right? Human resources, they would try to manage. You know, it's considered bad if a company has a high turnover rate, right? It means they keep hiring people and people keep leaving. Either managers are firing them or people are like, this job stinks, I'm out of here, kind of thing, right? One or the other. High turnover rate is not a happy thing. So this is a graph. It's showing the average rate of change of the percentage of new employees. Okay. That's the percentage that are new. Okay, gotcha. So what that, let me make it more real for you. That means in 1996, come up to here. Looks like it's about right there. It looks like it's about 6%. That means in 1996, if you come up here and go over, I think that'd be about 6 right there. This, you know what I'm doing right there. In 1996, 6%, this is percentage, right? 6% of the company was new people. It was their first year. Okay? And then here's the height. It looks like in the year 99 or so. What is that? Is that 18? 18% of the company. In the year 1999, looks like 18% of the company, almost 1 in 5 people, almost 20% of the company was new employees. They were there for their first year. And then it kind of went down, then it went higher again. So that's just showing the fluctuation. That's new employees. So they really should have put in new here. Where I'm getting the new is they said it somewhere. Where'd they say it? There it is. New employees. Was the average change of the percentage of new? All of a sudden they put in the word new, so I think, oh, it was new all along. It was. I guess that's new people. That's new employees. Does that make sense? What's happening? That's the percentage of the company that's new people. So you basically you want that to be kind of steady. You don't really want that going up and down. That's kind of a bad sign. Well, I should say this way. You don't want that to be too high. You don't want a bunch of new people because they won't know their job, and it makes you wonder why are people leaving if we have new people all the time. If everybody's leaving, nobody's staying longer than a year. That's a bad sign. So, all right. So, how do we figure this out? So what do they ask me? The average rate of change. Like how much did it change from 94 to 2000? Between 1994 and 2000, how did what was the average change in the percentage of new employees? Well, let's find those two particular spots on the graph. Again, this is new employees. In 1994, which is right there, huh? Nobody was new. There was nobody new. They had been there longer than a year. They went a whole year without hiring anybody new. That make sense? You been at those jobs where you don't want to stay longer than a year before? My daughter had that experience. My oldest daughter had that experience. It was a good motivator for her. About a year and a half ago, she worked at I'll just say a steak place to remain unnamed up north. It's actually a steak place I really enjoy to eat at. So I can say it. It's fine. Yosemite Ranch. I go there with my wife on her anniversary. It's a little more. I can't go there regularly. The teacher's salary won't afford that regularly. But on an anniversary, anyway, my daughter got a job there, and because she wanted to make tips and thought this would be good money during my college years. Well, it wasn't a very fun place to work. The management was just not the most user friendly. She'd had another job she loved, and that job was a shock for her. They were not always the most, and I guess the turnover rate there is pretty high. And she said everybody there hates their job, but they're just there for money. Anyways, it was a great experience. She was inside that job for like a year, and I remember her telling me a story one time. She said, yeah, Dad, one time I went back to the back, and one of the assistant managers was on the phone, and she was talking to somebody, and she was really upset, and talking, and she said, yeah, I'm at this dumb job, and I hate my job. The assistant manager was saying this to somebody on the phone, and I can't leave this job. I'm stuck here because I made bad life decisions. And she hung up the phone. And that's exactly what my daughter said. They were all of them there were trapped because they didn't have college degrees. And there wasn't, they made good money, but there were no other jobs they could get that would pay that much without a college degree. Anyway, it was great. My Emma girl was like, I am going to college, and she was already in college, but she was like, I am going to stay with college and get my degree and get a job I enjoy. I was like, good, this was a good experience for you. This is the world, honey. All right, so from 1994 to sometimes mom and dad's blah, blah, blah is not enough. The world can speak. All right, so from 1994 to the year 2000, it went up a lot. So what is that? Is that 18? That's the one I did a minute ago, right? Or no, I can't tell. Is it? Yeah, it's 18, isn't it? Am I doing that right? It's like 8. I think it's hitting at 18. I'm just finding where the dot is. Y'all with me? I'm just finding. This is the Y2. You get it? This is the Y1. This is the X1. and this is the x2. So we don't have to plug in anything. You just look at the graph. There's two dots. Each dot has an x-coordinate and a y-coordinate. Right? The y-coordinate is 0. The x-coordinate is 94. And then this dot has an x-coordinate 2000. This one's 1994, x-coordinate. And a y-coordinate 18. That's y2. Whoops, y2. 18. Is that making sense? So, what is average rate of change? You remember, it's slope, which is what? y2 minus y1 over x2 minus x1. So they're basically saying, hey, from 94 to 2000, how much did the number of new employees go up by on average? Well, it went up to 18% from 0 over 2000 minus 1994, 6 years, huh? It went up 18% over 6 years. It went up 3% per year on average. That make sense? You see, I like that they give real life things. That always helps with math and science. When you get something where not just numbers and X's, you know. Here's something real. Percentage of employees. Do you see what happened right there? So from 1994 to 2000, which is a 6-year period, over those 6 years, the percentage that were new went from 0% up to 18, huh? This dot was at 18% were new 6 years later. So that means it went up on average by 3% per year. On average, the number of new employees went up about 3% per year. Now, it didn't exactly do that. Sometimes it went up real fast and then slow, but on average, during those years, the percentage of new employees was rising 3% per year. Is that good? So that's our answer. So these are nice. These graph ones are nice. You don't have to plug in any functions. Just find the two dots, two x values, two y values, difference of y's over difference of x's. Slope, rise over run. Let's type it in. Was this 3? Here, I'll look back. It was 5. So number 5, part B. Oops, my 5s always just look terrible. Number 5, part B. Where are we going from 2000 to 2006, right? So same question. Now they want to know from the year 2000 to the year 2006, what was the average rate of change of percentage of new employees? So find the two dots. So find the dot at 2000. Right, here's the year 2000. Boom, there's the dot. Looks like it's at 18, right? This is the x value. This is x1, y1. And then the other one is 2006, which should be here, huh? 2006. And that's it. Looks like 22. That's your y2. This is your x2. Is that making sense how I'm finding those? I'm just finding the two dots, the dot that's above the year 2000, the dot that's above the year 2006. My daughter got a job this summer she's super excited about. She was afraid she might have to come home and work at Steaks again. She got an internship selling pharmaceutical sales, which is what she wants to go into in the Bay Area. So I'm not even going to see her over the summer, but she's super excited to be doing something she enjoys. She's like, this is why I went to college, so I can get a job like this. Making sense? So you get that? So y2 minus y1 over x2 minus x1, slope, average rate of change. So it's going to be what? 22 minus 18 over 2006 minus 2000. So what is that? That's 4, 6. I guess we just, do they want to fract? I guess we could reduce that to be 2/3, huh? Or do they want a decimal? What do they want? I don't even remember. Let's go see what they want. 2/3, or you could divide it with your calculator, get 0.6666. If you wanted a decimal, that'd be 0.6666, right? 2/3. Yeah, the 6's go on forever, right? If you divide 4 divided by 6 or 2 divided by 3, 6's go on forever. And so how do you change it? Or no, yeah. So, and they want, do they say 2 places? So round it to 0.67. Remember, whenever you stop, you look one to the right. The one to the right's 5 or more, you round up on that. So 0.67. What does that number mean? Real life. What does that mean? Can anybody put that in real life? What's that? 6.7? This is 0.67. So it's less than 1%. It's less than 1%. It's already, by the way, it's already percentage. We don't have to see, it's already percent. We don't have to convert anything. It's already automatically in percentage. So it's less than 1%. Right there. Meaning, during these 6 years, from 2000 to 2006, the percentage of employees that were new went from 18 to 22. So it went up less than 1% a year, huh? It only went up 4% during 6 years. So it went up less than 1% per year, specifically 0.67% per year. So it slowed down, but it's still going up. That's not good. You're still having more turnover, but at least it's not rising as fast as it was. Make sense?
Something happened in 02.
Something good happened. I know they got to back up there and go, what was management doing? That was good. Let's go back to that, huh? Exactly. These were the good years. People were staying around for whatever reason, and yeah.
Money was good.
Yeah, the pay was good.
They were making good life choices.
They were making wise life decisions. It is just sad. It is. Okay, so from 1992 to 1995, same kind of thing. Find the average. If you can do that, 92 to 95. Whatever it is the number of trips taken annually in a certain state's mass transportation system. So how much the state's train system or whatever is being used. It's basically a map, it's what kind of thing a transportation system department would look at, management, to decide how their usage is going. So the slope, y2 minus y1, x2 minus x1. How we doing? So 92 is right here. 95 is right here, isn't it? So this is, this is the x1, x2. This is the y1. This is the y2. They're just kind of giving them to us, aren't they? It's kind of nice. So y2, 7.4, y1, 8.6. And this is 1995 minus 1992. So what is that? Is it negative 1.2 over 3? Oh yeah, negative 0.4. That was the answer, wasn't it? Negative 0.4. 12 divided by 3 is 4. 0.4 in this case. Negative 0.4? So what does that mean? Give me real life. If you were in charge of reading this data to a group of people, this data shows, this calculation on this graph shows what? It went down. A decrease. 0.4 million. 0.4 million
People traveling.
trips. Yeah, trips for. Yeah, probably losing money during those 3 years. During those 3 years, from 1992 to 1995, on average, remember, slope is an average. Slope is an average. It's an average rate. The average rate of change, it was going down 0.4 million per year on average during those 3 years. During the whole 3 years, it dropped 1.2 million, dropping an average of 0.4 million per year. Remember, this is a slope. It's an average rate of change. Makes sense? And again, I say it's average because it dropped a little bit at first, then it dropped faster later, huh? The average drop was 0.4 per year. That's what a slope is. It's an average rate of change. Physics. An object dropped from rest from the top of a tall building on planet X. I've been there, planet X. Falls a distance, s of t equals 6t squared feet, in the first t seconds. Find the average speed of the object during the first 8 seconds of fall. Find the average speed of the object during the first 8 seconds of fall. You guys taking any physics? So physics is challenging. It's like math with all word problems, basically. It's pretty challenging. It's like hardest thing I did in junior college was physics. Okay, so how are we going to do this? Well, basically, you don't have to know a whole bunch of physics. If you just remember, what have we been doing? You see the word average, and what's a speed? Speed's a rate, isn't it? Average speed, average rate, that's the same, it's a synonym. So you just read average rate, go right into it. Go right into what? y2 minus y1 over x. The whole section is this, the whole section. Average rate is a slope. Okay, so what are my two x values, do you think? That's a little tricky. It says the first 8 seconds. So some kind of object, it's like they're dropping, they took an object and from rest up, they held it over the ledge of a tall building, they took a stopwatch and they went, go! And they let go of it and they clicked the stopwatch, and during those 8 seconds, the object fell faster and faster and faster and faster and faster. It's 0 and 8. Yeah, so the two times, the two x values are 8 and 0, huh? The 2 points in time that they're saying during the first 8 seconds, from time 0 to time 8 seconds later. So during that time, and what am I going to do on the top? What do I always do on the top? F of 8 minus F of 0, huh? And that would be, yeah, you could say S if you want to be more technically accurate. It's S of 8 and S of 0, but whatever, who cares? It's that function. Plug in 8, plug in 0, subtract that over 8 minus 0. Same thing as the other ones, huh? Why that function? Because that's distance, right? What is speed but distance over time? Miles per hour, that's distance over time, isn't it? The S function is distance. So it makes sense. That's what average speed is. Change in distance over change in time. So S of 8, plug 8 in there. So that'd be 6 times 8 squared minus 6 times 0 squared over 8 minus 0. See what I did there? I just plugged in 8 and plugged in 0 to that 6t squared function. That 6t squared, you plug in the time, it'll tell you the distance the thing has fallen. If something falls off of a ledge or out of an airplane, as it falls, its speed will go faster, 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 faster. Will it increase in speed all the way to the ground? You know anything about falling objects? You ever heard of, what's it called, terminal velocity? That means there is a maximum speed that a falling object will reach. It won't keep going faster and faster forever. Basically, it'll keep speeding up, speeding up, speeding up until the push of the wind resistance equals out with the pull down of gravity, so that it's reached maximum speed, what's called terminal velocity, terminal ending top velocity. So there is a maximum. So if you throw a rock out of an airplane, or if you jump out of an airplane before you pull your chute, there is a maximum speed you'll reach until the wind is pushing up on you so hard that it's equaling out the acceleration due to gravity pulling down on you to where you've maxed out your speed. You won't go any faster. Terminal velocity. This isn't a physics class, but I like physics. All right. So 6 times 64, what's that number? Thank you. 384 minus 0 over 8. So it's 384 over 8, huh? 48. 48 what? I had my old physics teacher, Mr. Grimes. I had him back in the high school days. If you ever wrote the answer 48, he'd be disappointed with me as a math teacher now. He'd say, "What is that, Heron?" He said that a few times back then. 48 what? If you didn't give the units, for math, we're just all about the numbers. Physics, they're like, "What is that? 48 what?" He would always say, his line was, "What is that, Heron? 48 dogs in the kennel? Is that 48 dogs? What is that 48 there? What is that?" So what is that 48? Yeah, they're giving me the units, huh? It's feet per second. That's the rate. That's on average, the speed increased 48 feet every second that thing was falling. It actually, the way you would say it is it's 48 feet. The speed increased 48 feet per second every second. So in other words, when you released it, it was going 0. 1 second later, it was falling down at a rate of 48 feet per second. Another second later, it was going down at double that, 96 feet per second. A third second later, it was add another 48. It just kept increasing its speed downward by 48 feet per second every second. And they call that acceleration, feet per second per second. It's the rate of change of velocity. Not a physics class. Of the same, all these are the slope formula. They did it with a graph, they did it with a formula, now they're doing it with a table. So they're saying, all right, average velocity from 1 to 3. Oh, velocity, that's another word for speed. That's another word for rate, isn't it? Basically. Velocity just includes the direction. Anyway, it's not a physics class, good enough. They're all the same. They're basically rate. So that says average rate, average speed, average velocity, same thing. So what are we going to do? y2 minus y1 over x2 minus x1, what we've been doing the whole section. Okay, now, what do you think? Let's start with the bottom. The bottom's always easier, huh? What do you think about the denominator? What do you think is my x2 here in part A? What's my x2 and my x1? Yeah, exactly. This is the x1, this is the x2, huh? 3 minus 1. Good. Now, what do you think? There's no picture here, and there's no formula. Do you all see they're just giving you 3 different looks? There's no picture this time, no graph where I can just go up and find the dot. There's no formula to plug into. See, there's no formula anywhere. So how am I going to find my y values? Not by plugging in, not by looking at a graph, but by looking at the table. They're just telling you the function. See, this is the function. Right there. This is basically an x, y table. Except it's t and s of t, whatever, same thing. X, y. So what's my y2? It's the 5. It's whatever goes with the 3. Yeah, up there goes a 5. Whatever goes with the 1 is 1. You don't need that line there. Everybody see how I got those? So, see, they just keep doing 4 over 2, 2. Just doing the same thing, aren't they? They're just saying, hey, graph, table, function to plug into, it's all the same thing. It's all rate of change. Average rate of change is slope. Again, feet per second. See what we got. 2 more. I move on. Derivative. Let's see. Better do this with you. All right, so how about you do part A, and I'll look at my notes. See if I can remember part B. Let's see if my notes remember. What do we do there? Marginal. Find the marginal revenue at 5,000. So 0.004. Let me see. 0.004 times 5. I bet it's 20. Let me. So I'm just going to do part B. I don't got time for part A. I didn't realize they do this right at the end. I'm going to show you something called the derivative. And I'm not going to show you their way. You saw all that mess they were doing. Ain't going to do that. So we're going to take this little formula here. You can impress your friends with this. This is calculus. We're going to do the actual derivative, it's called. So that's the R of it. That's the R function, right? I just grabbed it, 11x minus 0.002x squared. Here's how you take when they say marginal. That's the word here. Marginal revenue. Now, whenever they say marginal on something, that means small. The margin of a paper is the small edge of the paper, right? And you see, that only went up by a marginal amount. What does that mean? A little bit. So marginal revenue, the average rate of change in revenue, the marginal means how fast is the revenue changing if instantaneously. Yeah, I don't have time to give you more theory about it, but it's like right at that instant, how fast it goes. Not the average, see on part A, you're doing the average, like from as X, what is it, from producing A. As you go from producing 1,003 items to producing 1,008 items, how much does your revenue go up? Well, that was part A. During that zone, right? But in part B, they're saying right at 5,000, right at that instant, marginal change, meaning almost no change at all. Right at that instant, when you're producing 5,000 items, how much does it go up? All right, I should have got here quicker to explain that better. Marginal revenue, you got to do the following thing. Each letter, for each letter, here's what you take, or for each letter, the power multiplies down to the front and subtract then subtract 1 from the power. At the end, plug in x. Yeah, that's good enough at the end. Okay, so in other words, here we go. This is an official calculus derivative shortcut way. I'm giving you the shortcut way. There's an understood 1 power up there, right? You take that 1 and you multiply it down. So it becomes 11 times 1. You with me? So here's the rule. The power multiplies down to the front. Then you subtract 1 from the power. So it becomes x to the 1 minus 1, which is 0. Minus, tracking with me, take the 0.002. What am I going to do with the power 2 here? Same thing, bring it down to the front, multiply. And what do you do to the power? Subtract 1 from it. So just see, that's how you do a derivative, shortcut style in calculus. Yesterday you probably did 1,000 of these, huh? At least 500. So see what I did there? I brought down the power, right? And then 11 times. Now what happens? What is x to the 0? It just vanishes. Anything to 0 power is 1. This is gone. Minus, and this is 004x, right? 2 minus 1 is just x to the 1, or regular x. Did you see what happened there? So that's how you do marginal revenue, which is really a derivative from calculus. This is part B. Oh yeah, this is all part B, by the way. I skipped part A. I'm not doing part A. This is all part B, marginal revenue. So again, what do? I take the power, multiply it down the front, subtract 1 from it. Take the power, multiply it down the front, subtract 1 from it. Get to here, and then at the very end, you plug in your x. What is your x? Well, they told me 5,000. So it's 11 minus 0.004 times 5,000. Hit the buttons on your calculator, and you get minus 9. Right? Did I do that right? Yeah, minus 9. Now why? That's why I kept typing in, or things like it. But then all of a sudden, notice they changed to dollars when they used to be talking about thousands. So that means you got to make that minus 9,000, since they took the word thousand off, which was really dumb of them, I think. So there we go. And the last one's just like it. So that's a derivative. Sorry, I kind of ran short on that one. I forgot that we had that near the end of the section. Any questions I can answer on that? Makes sense? Bring the powers down, subtract 1 from the power. That's a derivative from calculus. That's when do you do that? When they say marginal revenue. So on the exam, the final exam, and we'll go over one of these on Thursday, because one of the first questions will say marginal revenue, and we'll do that. That's when you do that, marginal